Now if you've been thinking to yourself, man, I really want a mini Wally to follow me around like a faithful puppy. Well, look no further. This here is that dream with a reality. In a reality, with 3D printed parts and the power of an Arduino Nano, well, you got this. It's pretty vocal. Also, fair warning, Baby Wally's probably gonna make your other robots jealous, so damn it, Timmy, put Baby Wally down. Okay, this is the last, don't you do it. Don't you, that's gonna go ahead and jump right in on how to build the heart and soul of Wally, which is this PCB that I built. The Arduino Nano just hooks right into, do you mind? Okay, the Arduino, this is a custom PCB that I built, which you can just hook your Arduino Nano right into. This just makes everything a lot easier and a lot neater. You don't necessarily need to have it, but I do recommend it if you're trying to like make Wally long lasting and survive. Otherwise, you're gonna be constantly like taking it apart to redo connections and whatnot, because that's what I had to do with Wally number 1. All right, I've got a couple tools here that are gonna make this job way easier and actually are necessary. So, first off, we've got a glue gun. I tried to eliminate all the need for using glue gun, but there's still a couple parts where this just... Next up, we've got a soldering iron. A pair of pliers will make your life a lot easier. Some little wire cutters, some kind of little prodding device. Same story, moving stuff around. It's a cramped space, so anything you can get like this. And then of course, you need an Allen wrench set. You only really need like the smallest Allen wrench, and this is just for Wally's tracks. Step 1, I'm going to take these 10K ohm resistors, and I'm just going to go ahead and solder those right into this slot right here where it says 10K ohm. When you go to solder the plugs on, you want to make sure the open side is facing towards the Professor Boots logo. Now, one thing to note about the buck converter is that you actually just want to go ahead and cut this wire trace right here. It might be really hard to see, but I'll make sure to highlight it. And then you'll just go ahead and solder the two 5-volt pads together. Before we put the button on, you're going to want to go ahead and put just one pin on the little switch pad, and you're going to want to put it on the back pad of the switch pad. Alright, next up you're going to want to go ahead and solder on these two sets of 6 pins, and these are for our H-bridge, which control our 2 DC motors. Now the reason why we want to solder the pins first is so we can put them on, snip the backs, and then put the Arduino Nano on without them running into each other. Alright, next up all I'm going to do is I'm just going to go ahead and solder the pins right onto the Nano as normal. I'm going to leave off these top ones though. Alright, now that I got all the pins soldered on there, I'm just going to go ahead and slide it right onto the PCB. Alright, once you've soldered the Arduino Nano on, you want to make sure to go through and snip all the pins off the back side. That way we can go ahead and slide our H-bridge on without them running into each other. I'm going to go ahead and throw this H-bridge on, and you just want to make sure that the EEP lines up with the EEP on the board. So it's just going to end up sliding on just like that. Alright, now what we're going to do is we're going to throw these 2 wires onto these 2 little pads right next to the Bluetooth, pads. And these wires will run to a switch, and this switch turns Wally on and off. Next, I'm just going to go ahead and throw some 3-pin connections on the left arm, right arm, head rotate, compartment door, and speaker squares that I have set up here. So I'm just going to go ahead and break those up and solder those on real quick, and then we'll move on to the next step. I'm going to go ahead and throw on this XT30 connector, and this is where our main battery is going to plug into, and then I'm just going to throw on our HM10 Bluetooth chip, which will sit right over the top of the Arduino Nano, and then after that, the only thing we got left is this little LED. For this HM10 Bluetooth chip, I'm just going to go ahead and take these pins and bend them straight down. That way we can set it right in the slot where it needs to go. So it's going to end up looking like that. I'm also going to go ahead and trim the 2 pins right off the edges, so the outside ones. And we'll end up with these 4 in the middle. Alright, last but not least, I'm just going to go ahead and tack this little LED right onto the Arduino Nano. You're going to want to run the longer lead of the 2 to pin A4, and then you're going to run the shorter lead to ground. So it's just going to end up sitting just like that. Once you got Wally sold to this point, this is a pretty good place to go ahead and upload your code. So I'm going to go ahead and do that real quick. And then once I've done that, I'm just going to run a couple tests and make sure everything's working all right. So we're just going to do a little bit of this action. Upload. To get access to the code, click the GitHub link below, which will take you to this page. From there, you'll be able to directly download it. One thing to note is this flag PCM library. It's not accessible through the built-in library manager, so you'll have to go through the GitHub page and download it separately. This just allows us to use the speakers without interfering with the servos. All other libraries are available under the Manage Libraries tab. A couple things to double check before uploading the code to the Arduino is that you have the right COM port selected as well as the correct processor. If you have any issues, try switching between these 2. From there, just hit upload and you should be good to go. Okay, that's done. Here's the battery that we're going to be using for this project. This is just a little 300 milliamp tattoo LiPo. Right into this little XT30 connector. And then once I've done that, I'm just going to go ahead and flick our switch. So flip it to on, and you should see 3 LEDs. You should have a green one on the H bridge, you should have one on the nano that's red, and then you should have a blinking one on the H bridge, which is our Bluetooth chip, and it should be blinking red. So once you've got everything hooked up, go ahead and plug your battery back in. And then when you go to turn this switch on, make sure you listen, and you'll hear all these little servos actuating or moving. You'll hear speaker works. And I heard all the servos go. So it looks like it's already running through its first little autonomous command. So once that's done, I'm just gonna long press this button. You can see that the LED flashed once. Now we know we're in Bluetooth mode. So to make sure that works, I'm gonna pull out my phone. I'm gonna open up the Handy Dandle Dabble app. Okay, so I'm gonna find BT05, because that's this chip, and it's connected, so now I'm gonna make sure it works. We've got forward movement, back movement, so the motors work, those are all just fine. I'm gonna make sure the compartment servo works. So with this servo's actuating, I'm gonna make sure Wally's voice works. That works, I'll make sure a program sequence works. Yep, so you can see the linear servos going. That's a success. Now we're good to go ahead and disconnect everything, and we can put this into Wally knowing that we're not gonna have to take it out later because something wasn't soldered correctly or was broken. But yeah, good job folks. If you made it this far, you're doing great. All right, so we've got all our PLA and TPU parts. You just wanna go ahead and clean these up before you start to use them. We're gonna go ahead and start off with our main housing, and we're just gonna go ahead and slap our 2 DC motors in. Be very generous when you apply the hot glue, as there's quite a bit of torque that goes on these when we put the tracks on. So just make sure that you really get that inside crease, or you could even stick them down if you want. And then here I am putting the battery in. You can either secure this with some hot glue or just kind of leave it. I like to put a little bit of hot glue. Right now we're just going to go ahead and put this little, it's like a separator between the compartment servo and the motors. It just rises it up a little bit so that the arm can swing free. Just want to make sure that that's nice and secured. I'm going to go ahead and plug it in, and then we're going to align the compartment servo before we get anything ready. That way we know it's in the right spot. So once it's been in the right spot, we're going to put a little servo horn on, make sure it goes back and forth all right. Here I am making a little hook for a metal wire, and this is the wire that runs from the servo to the compartment door. You're just going to want to go ahead and put some more hot glue down and then place your servo. Alright, after I've placed the servo, I'm also going to make sure that it still swings free and doesn't run into the battery or motor. And then I'm going to take the motor wires and glue them to the side of that separator. I'm going to go ahead and attach some floss to the linear servo and trim the end, put some hot glue on it, of course drop it. And then I'm going to attach this right to the side of the main housing, which you see here. And how I have it right now is I have the gears on the bottom. Flip that up and actually put the gears on top. It works much better that way. Here I am test fitting the door, and then I'm going to put some hot glue in these little tabs on the bottom of the door that connect it to the body. This just provides a nice little hinge. I'm going to mark the wire where that hole in the door is so we can connect it. And then I'm going to bend it around that little hole so that it should hook in. For the tracks, I'm going to go ahead and put on these little roller bearings, and they're cone shaped. You want to make sure that the smaller end of the cone goes towards the track support. And these just help kind of reduce the friction between the track and the support. Then I'm going to go ahead and attach those 2 track supports to this middle bracket with some screws or bolts. And then go ahead and attach that to the 2 holes that are in the bottom of the main housing. Alright, now that the door is in, make sure that when you route the battery wire that it goes under the linear servo, and try and get it shoved as far back as possible. Also note again that the linear servo should be the other way around, so the gears should be on top. Here's what it's going to look like with the PCB installed. This is just a test fit. I'm going to go ahead and pull the power switch through, as well as also notice that I pulled the balance plug through, and this is what we actually use to charge the project. I'm also going to pop the speaker in place. Now I'm going to go ahead and put some glue on the compartment servo, and I'm going to attach the head rotate servo just to start getting a little bit of structure going. This is a good time to go ahead and start shoving your wires into the back right corner of the chassis. It's all hollowed out, so you can shove all your extra wire down there. And then I'm going to go ahead and route it around the other side of the head rotate servo. I'm also going to mark each servo to know which servo it is. So for example, the compartment servo, I'm going to mark blue. That way I know what it is when they're all together and I have no idea which is which. I'm going to go ahead and put in the right arm. And once again, I'm going to route that wire into that right corner just to kind of hide it away from sight. And then I'm going to put the left arm servo in. Same story. Shove the wire down in that corner. And then I'm going to route everything out under the right arm servo. And I'm going to go ahead and connect all the servos into the respective 3-pin connections. Right now is a good time to really try and tidy everything up as much as you possibly can, because it's really going to get kind of cramped here in a second. So you can see I'm trying to get the floss in the right way. And now I'm going to go ahead and connect the speaker wires. The square is your ground, the middle one will be your 5 volts, and then the other one will be your signal wire. So you can solder them to the respective places. Here I am routing the floss through a small PTFE tube. You could use a straw or anything, and then I'm going to go ahead and glue it right to the servos. Alright, I'm going to go ahead and route the floss through the top, and then for the front gray grill, there's 2 knobs that you want to make sure just snap right into the yellow piece. Then the back of the grill will kind of hold onto the back of the chassis. To attach the head to the neck, just go ahead and use a small chunk of 3D printer filament, and this will just kind of give it a nice little roller motion. Route the floss up the back of the neck, and then we can go ahead and glue this extension piece on the back of the head. This is just to provide more torque because the linear servo isn't very strong. I just wrapped the floss a couple times around one of those holes and then glue it in place with some hot glue. Now it's time to go ahead and install the drive gear, and I just like to use a little bit of hot glue and then slide them in. You want the teeth of the drive gear to line up with that middle part of the other 2 roller gears. Now just go ahead and pop the track on, and it'll be pretty tight to start with, but you can always loosen it up later. Now I'm going to go ahead and slide the lower arm and upper arms together. You should be able to move the hand to whatever position you like, and then to secure the arms to Wally, just use 2 screws and you'll be good to go. We've officially given birth to our little, adorable, loving baby Wally, and I'm already anticipating the day that he takes over the world, so yep. I hope you enjoyed the project. Thank you so much for watching, and have fun tinkering.